Hello, everyone, and thank you all for joining us today. Today, we are with Ty Kenny, Ken Hatton, and Derek Gallagher from Druid Software, an Irish software company founded in 2001, and they have become the market leader in providing 4G and 5G private core network software platforms. They developed the 4G, 5G cellular network technology platforms with unique features designed specifically for fixed wireless access. Their Raemis platform is a mature technology in use today all throughout the US, Asia, and Europe for mission critical environments. They have made managing and operating 3GPP compliant 4G and 5G EPC networks really easy for WISPs. Some of their platform's benefits include a simple management interface. They are vendor neutral and work with any vendor's eNode Bs and CPEs. It easily integrates with existing CRM systems, and it's also a fully scalable, future-proof solution capable of 5G. We have a lot of really good information to cover today. Tig will kick it off for us. Tig, the floor is yours.
Thank you, Jonathan, and good to be here. So yeah, just to introduce myself, I work at the Sales and Marketing Office in Druid. One of my primary jobs on the marketing side is to assist ISP suppliers for webinars like this, informational webinars, and also to look after our small vendor relationships like Airspan, Telrad, etc., and various other small cell vendors. My colleague Ken Hatton is on the call today as well. He works in the Sales and Marketing Office, also at Druid, and is the account manager for fixed wireless access business in the US and assists ISP supplies on the commercial side. And also Derek Gallagher is with us on from the CTO pre-sales office, and you can see links there to our LinkedIn profiles, etc. So let's just talk a bit about the journey so far. On-go CBRS spectrum is a relatively new concept, along with private networks and cellular for fixed wireless access in the United States. But Druid have been doing this for almost 20 years, as you can see there in this timeline. Initially for the aviation industry, for in-flight, and then after we productized our application, we leveraged spectrum in the Dutch market and in other European countries to, over 10 years ago, to be deploying into healthcare. You can see there almost 6 years ago in Japan, Philippines, and Singapore, that market started to get going. We've been deployed with operators over 5 years ago in Europe already. IoT, cellular, container tracking, telemetry, all of that kicked off about 4 years ago for us with spectrum in other parts of the world. And then with the transition from Tetra, push to talk, across to 4G technology, man down lone worker, which links in very nice to industry, that use case as well. That's about 3 years ago that innovation started. And then we come full circle back to the United States, and over the last couple of years, how we've been focusing on CBRS and on-go. And fixed wireless access is a really important first step. And then just to speak to the business models and the market landscape, I mean, today is all about fixed wireless access, certainly, but we've noticed several wireless internet service providers looking at healthcare, looking at enterprise in building. Some of the public school scenarios we're going to talk about today for fixed wireless access actually fit an in-building connectivity profile as it happens. So fixed wireless access is very important, absolutely, for the urban unconnected and for deploying rural broadband. But after that, industry is another very large segment for business critical, for manufacturing, mining, oil and gas, power utilities and transportation, as you can see there, healthcare and education. Neutral host has become very topical. If you haven't heard of the term, it's multi-carrier operators being deployed on single small cells with private networks, etc. And you'll see a lot of this in stadiums, in public spaces, etc. And there's a lot of news about us out there with our partners who are very important aggregators to bring those different carrier connections together. And then finally, the mobile operators and mobile virtual network operators are busy deploying solutions with CBRS. And then just to talk about countries actively exploring new licensing models. I mean, obviously the United States, very, very important, could become the biggest private network market over the next couple of years. A lot of spectrum, very large economy, 50 states, one regulator, all speaking English. It's a very, very important market going forward. And then you can see, over the years where we've done business in Europe, in Scandinavia, in the UK, France, Germany, the Netherlands, and in Asia, etc. So who are Druid? So Druid are a software development company based in Dublin, Ireland. Our cellular technology platform is called Raemis, which stands for Radio Emissary. So we act like an ambassador between the public and the private network. That's where the name is derived from. And then our software is used to deploy solutions for enterprise, fixed wireless access, mobile edge computing, public safety, mobile network virtual network operator infrastructure, and for IoT Internet of Things. And then we provide customization and technology consultancy services as part of our software offering as well. How we do business, ISP supplies could be, are a very important partner and could be a distributor or channel in this model on the right here. We've got examples with the likes of Airspan Networks as global OEMs deploying our software and their hardware in Asia, Europe, and the United States. But needless to say, these partners are very, very important in bringing the spectrum, the small cells, the devices, the complete solution along with our core software together and delivering a solution then to the business end user or to the unconnected home. We never invoice the business end user directly. We're always working through these partners and wireless internet service providers. So what is Raemis? The Raemis is a 3G PP compliant 4G and 5G core network, and we've developed unique features specifically for the fixed wireless access market in that product. It's a mature technology, and as you've seen there, it's in use today by internet service providers and enterprises for mission critical environments in the US, Asia, and Europe. Some of the features we feel are most important are the simple management interface, which Derek will demonstrate later. The ability to be able to work with any vendor's eNode B or CPE equipment is really important. So if you've already invested in small cell technology, the ability to be able to work with another core like ours is really important. The integration with existing CRM systems, that flexibility is really important. Layer 2 networking capability, to be able to scale down as well as scale up. So as you build your network at the beginning, it more than likely will be small. So the ability to be able to start small and then scale up into 100, 200,000 subscribers is very important. And then that easy transition into 5G capabilities. You may have seen last weekend, we delivered our latest 5G release, but as that 5G ecosystem develops, we've made sure that our 4G interface and 5G interface are very, very similar. So as people get to grips with the technology, they won't see a huge difference as they transition across to 5G when they're ready. So Derek, would you like to talk about some of the challenges facing wireless internet service providers when using cellular?
Yes, thanks, Tyg. Hello, everybody. Thank you for listening. So just continuing on from what Tyg had mentioned, really, the Raemis platform is a mature technology. We've been deployed, as Tyg has mentioned, we've had our mini CBRS about a decade ago. And since then, we've been deploying a product into enterprise and a lot of deployments in fixed wireless access. And in this slide here, what I've done is I've taken 5 of the challenges that I guess represented to us in our discussions over the last couple of years in the US. I've just taken 5 what I think are important. I guess there's others, and I guess some of these may not be important to some people, and some of them are very important. But what we're trying to show is some of the challenges that we believe WISPs are facing when using cellular technology. And the first question, I guess, is how do I integrate the Raemis fixed wireless access core into existing business processes? And again, that's an important question. So we're not asking you to, hey, how do you make LTE work? We're asking you, how do you make this fixed wireless access core integrate with your business processes? So I guess today what we have is, we have this picture here today where you have possibly, some tools, some CRM tools, billing tools, management tools. And again, we've just picked a couple at random. And really what you're doing is you're managing some sort of CPE or residential gateway equipment or some device on the customer premise. So what we're trying to do is that you can see on this diagram at the bottom here, we're trying to provide the functions that include CPE bandwidth and QoS provisioning. So how do I limit or how do I differentiate between my different customers in terms of what bandwidth I'm going to provide them on the radio interface? What QoS, what priority do my customers have? Do I have different service levels and different types of customers? Billing, maybe I'm interested in usage statistics, how much usage, can I deliver on SLAs? I can verify that, hey, yes, this device is up. It's doing this much data. IP management and layer 2 access to the RGW. So a lot of systems today, the IP addressing and the networking is managed from central servers. Maybe it's a DHCP server, maybe it's a Radius server, and they're managing the IP addresses of these residential gateways and this equipment on the customer premise. So how do we manage that? LTE by design is a layer 3 network, and a lot of the assumptions that may be made today, in terms of assigning IP addresses to the equipment on the customer premise, they may not hold true in standard LTE networks. So we try to address that. Obviously, then the CP authentication is very important. How do I authenticate my users? Obviously, the SIM card is a big part of that. So every CPE or every UE has a SIM card. How do I add that SIM information into my system? How do I tie that into my existing systems, my existing CRM systems? We'll talk a little bit about that. And then there's the option of VLANs, right? So can I map different groups of users onto different VLANs? Possibly, if I have enterprise customers, how can I tie those endpoints together into a customer VLAN? So we'll look at a little bit about the CP and service management. We'll talk about radio profiles for CPEs. And again, it's the radio. The RF is the bottleneck, right? That's the resource that we're trying to manage here. So we want to be able to make sure that we can design specific profiles for specific services that we're selling to our customers. IP address assignment, how do I assign IP addresses to these devices? Again, how do I manage the bandwidth? How do I manage the quality? And can I generate some billing information? On the networking side, again, we're interested, I've already mentioned that by design it's a layer 3 network, but we're going to make it look like a layer 2 network. So you'd have the same, I guess, in theory, the same IP address access or IP access, or sorry, layer 2 network access that you enjoy today, that will still hold true. Then obviously the other challenge is the complexity and cost of a cellular network. So cellular networks by design, originally designed for consumer model, consumer use cases, volumes of users, mobility and roaming being two of the big features. So the fixed wireless access use case, to be quite honest, is actually the simplest, and it's a very, very simple use case in relation to mobility and mobile networks. So trying to buy a solution or a core that was designed primarily for enterprise or for consumer cellular technology and trying to fit that into the ISP model or the fixed wireless access model, it's just, you're just buying something that's not fit for purpose. It doesn't scale down well. It doesn't have this business systems integration points, and obviously it's got features that you don't need. So we try to address that. Okay, so if I look at the benefits of the Raemis fixed wireless access cellular core, and as you can see, we've pretty much kept the same diagram from the previous picture. So the idea here is that we're trying to show, yes, look, the functions that we were concerned about in the previous diagram, they still hold true. All that's changed is you can see that the device that's on the custom premise, it's a 4G and a 5G UE, 4G or 5G device, and we still have a residential gateway at the custom premise providing the local connectivity. So it's a 4G or 5G backhaul or radio link back to the fixed wireless access core. And you can see that we're trying to maintain the same level of functions. We're trying to maintain VLAN support, CP authentication, IP management, billing, and bandwidth and cost management. All of that is doable with the Raemis APC, and we have a management interface that enables us to manage all these features in a very simple way. We also have a REST API, LDAP interface, and AAA interface, which enables us to integrate some of those features with existing systems. So if you have existing billing systems or CRM tools, for example, Free Radius, Sonar, Azotel, any of those systems, it's relatively easy to map them onto our platform. So that's the simple management interface. The installation is easy. We believe that if you have a hardware with CentOS 7 installed, we provide a script and you'll have an EPC up and running in 15 minutes. CP authentication can be done by Raemis or external systems like Radius or Sonar or whatever. So it's easy integration. IP management of the CPE, we can use your DHCP server, or as I said, other external systems for your IP management. We've mentioned the Layer 2 network architecture option, and we've also mentioned that we can map user traffic to specific VLANs, specific network interfaces, etc. Okay. So this slide again and we'll dig a little bit deeper into this in a few minutes, but again, it's just summarizing pretty much what we said. It's about simplicity. It's about a simple management interface. It's about knowing what's happening with your radios, with your end devices, the IP address of these end devices, the quality of service, the bandwidth going through the network. It's being able to manage this through a single interface. So we believe that's simple. We believe it's much more intuitive. Even though, as Tig mentioned earlier, this is a fully compliant 3GPP core. So we'd have all of the acronyms and all of the 3GPP interfaces that you would expect. They're all there, but we hide them. They're abstracted by our PCN GUI. So under the hood, we still talk S1U, S1C, S6A, S5, S8, PGW, SGW, all the acronyms that you're going to hear left, right, and center in relation to LTE and 5G. We have them, but we just hide them. We talk VLANs, we talk DHCP, we talk IP address management, and we talk quality of service. Okay. So this slide, I guess, is probably the key technical slide in terms of the main point I'm trying to get through in terms of one of the unique features. So really, what we have on the left-hand side are your customers, your end customers, right? And these customers or these devices, we can easily import into Raemis, and I'll show you that in a second. But what we can do with these groups or with these users, we can create groups, any number of groups, any names, any definition of groups, and we can organize or segment our users into these groups if we wish. And that's on the left-hand side. On the right-hand side, we have your physical infrastructure. So that's network ports that are coming from the server into your network. They're VLANs, basically network interfaces, right? That's on the right-hand side. So in the middle, we have the network objects. So this is what Raemis does. It's the key to the system, right? So this is Raemis defining these network objects that basically tie groups of users on the left-hand side onto specific VLANs or network interfaces that connect directly to your network. So you can segment your users that are going to come onto your network on different VLANs or different interfaces. But most importantly, the middle part, the radio part, is you can assign priorities to the traffic for these users on the radio. And you can assign quality of service, minimum and maximum bandwidth. And I'm going to jump straight from this slide into the Raemis interface, which gives you a little bit of, I guess, a concrete example of this. So this is the user interface. It's just a small test system I have running here in the lab. We have this deployed in a number of sites across the US for fixed wireless access use case. And this just gives you a feel for what it's about. So as I said, you should be able to build this and deploy this for your first system in about 15 minutes. What you generally get then is when you order the system, you'll receive a bunch of SIM cards with a CSV file that will describe all of your the SIMs, the security information on that SIM. You'll import that with a simple import click here, and the CSV file is uploaded into Raemis, and all your users are then activated on the system. And you can see here I have a number of users activated. Again, there's filters, so you can click to see which users are present, see the IP address of a user. I can see which network this user is on. I can see the IMEI, which is the equipment identifier, DUE. So there's a lot of things I can do here just in terms of looking at my users, looking at the radio this user is attached to. And again, very, very simple to import. Simple CSV file, and everything in this system can be exported to CSV files. So we can export, keep this as my template for users or SIM cards, update it, and add to it as necessary and re-import it. If I look at the dashboard, what I'm interested in my users. How many users are on the system? In this case, I have 572. Detached, I have some users here, 6 are on data, and you can see it gives you an idea of how many are active and how many are inactive and how many are on calls. In this case, obviously, we're only interested in data. The other thing is my radios. How many radios are connected? There's my radio interface. It's on VLAN 170. You can see that I've got, in this case, 4 radios disconnected, 3 connected, and no activity. Give me a sense of activity. So again, if you've got a large number of radios, you want to make sure that none are disconnected. You want to make sure that there's activity on them all, and that there's radios with users. Right, a radio without a user basically means that yeah, what's it doing there? We also see we have a SIP provider pane. So the other thing that Raemis does is it integrates with commercial PBXs. So if you are offering a voice service, whether it's an ATA port or whatever it is, Raemis can integrate your UEs with commercial PBXs. So basically your devices at the edge become extensions on the PBX, or you can have trunk connections to the PBX. So voice services is available. This guy here is the network tab, and we've already talked about this, right? The view of my networks, the traffic that are going through my networks, the users that are attached to my networks, the interfaces on my LAN that they're connected into, VLAN 1001, 1000, for example. We talked about how after I've imported my users, it's relatively trivial then to create groups, right? So in this scenario here, I've created a bronze, a silver, and a gold group. Again, adding users or removing users from these groups is very, very simple. It's very intuitive. And again, this is all done through this user interface, but this user interface is using our REST API. So all of the features and all the functionality I'm demonstrating today can be achieved by integrating to our REST API with your systems or your management systems, if that's what you prefer. But you can see I can move users from group to group. I can add users. I can create new groups. And what ties all this together is the networks, right? So on this server, on the Raemis EPC, I'm going to have ports and VLANs. So this is my physical infrastructure. Here's my physical ports. I can manage those ports. I can set the IP address information, make it static, make it dynamic. I can create VLANs, add a VLAN. I can pretty much figure out what my IP addressing, how I want to configure the Raemis platform in terms of the physical ports and the IP assignment. I can do that through the interface. Once I've done the physical part, I've already done the users part. I've already done the groups. I've done my physical part with the networks and the ports and the VLANs. Now it's just tying those two together. And what we're doing here in the networks tab is we're creating groups, network groups, PDNs. And packet data network, in this example, the gold network, I click on it, and you can see it's really defining how this network interface is going to work. So when a UE that's part of the gold network attaches to the network, and the first question I have to ask myself is, how do I assign an IP address to that device? So in this case, I'm using DHCP from your network. So your DHCP server is going to serve the IP address to that UE. It doesn't have to be that way. I can click no, and I can create pools, IPv4 or IPv6 pools if I wish. But in this case, I'm just using DHCP. Again, outside the scope of this demonstration, but it is also possible to integrate these hooks with other services like as I said, Radius, for example, and that could easily serve the IP address for each of these devices if that's what you require. So let's presume that DHCP is the mechanism for assigning IP addresses. The next question I have is, who can access this network? And only the users in my gold group can. So I've selected my gold users. So that means no matter what APN configuration I have on my UE, that UE or that device is only going to connect to this network. So if one of my neighbors is tech savvy and he logs onto the device and he figures out, hey, I can see the APN name is silver, but my neighbor has an APN name of gold. If I change that, I'm going to be able to connect into the gold APN. It doesn't matter. Raemis will make sure it's on the right APN and the right PDN that you've configured. And this is very flexible. This means that you don't have to reconfigure the devices as you change APNs. That's all done from within the network. Again, making it simple. Once I have that done, once I have my users defined that are going to access this network, I've figured out how I'm going to assign IP addresses. Next thing I may want to do is, again, the radio resource is the key, is the critical element here. So for these users, they're going to have a QCI of 5. They're going to have priority 2, so very high priority, right? So again, if there's contention between my gold and my bronze users, these guys are going to take priority. I've also set the AMBR for the downlink and uplink AMBR. In this case, I've set 200 megabits. Maybe that's not realistic, but again, that's just an example. And the last part of this puzzle is to map all of these users and map this quality of service through to my interfaces, right? The interfaces on your LAN and your network. And in this case, it's going to VLAN 1001, but again, it's listing all the available interfaces. So again, what does this mean? This means when a device attaches that's in the gold network, it's going to receive its IP address from my DHCP server. It's going to have this priority on the radio and this AMBR on the radio interface, and all the traffic from this device is going to be presented on VLAN 1001, which means I can do various things there with that traffic if I wish. So that gives you a kind of a flavor of how we've tried to make it simple to show you really the key features all within one tab. Again, the rest of the tabs that may be of interest, obviously the dashboard, obviously user management is key, group management, managing, grouping these users, we've already talked about. Integration with commercial PBXs. Again, I won't dwell on this too much, but it is possible, and it's a very, very simple exercise. You're really just adding the IP address of the PBX that you wish to connect to. Cells, again, by design, as we mentioned, we're radio agnostic, so most of the cells, once they're configured with the MME address of Raemis, will connect, and with our plug and play enabled, you'll just see them pop automatically up on the dashboard. Where they're not enabled, some information about the PLMN ID, the IP address, and how active each of these cells are. Again, we have a concept of radio zones, so you could, in different territories, ensure that only certain radios, certain users can access, certain groups of users can access certain radio zones. Maybe useful, may not. But what is useful here is that in these radio zones, you can set time zones and timing information on the radio. So the devices on the custom premise will be receiving their time based on the time zone that they're in. So if your radios are displaced across multiple time zones, then you can create the radio zones. Network, we've already talked about. Alarms is what you'd expect. Again, simplicity is the key. We try to create these alarms very easy to use, very easy to see that it's obvious what the problem is. The system, again, we do provide redundancy. So in this case, I don't have a license, I don't have a demonstration, but if you wish to have active redundancy, that's possible. The whole system, as I mentioned earlier, the complete configuration of the EPC can be backed up to one configuration file and restored from one configuration file. So that makes it easy for you to deploy new systems, to restore system if it's if something crazy has happened, or if you need third line support, you can export the configuration, and the third line support engineers can then help solve any problems that you may have. Admin means that you can create different levels of users with different access to the interface, depending on what you want them to do. Obviously, some users you may only want to be able to view, some users will be changing radio or changing groups, some users may only be adding users, but again, just this flexibility. If you've got different users in your organization, they can have different access levels. Tracing, again, if there's a third line support issue, that needs log files, needs traces to be provided, then all that's possible through the user interface. We're not asking you to log in and run Wireshark or T-Shark or anything like that. And really, that's the kind of high level view of Raemis. I don't know, some of you may have noticed, somebody may have noticed the 5G symbol up here. So again, as we mentioned, this Raemis that I'm showing you here is our latest release 4.5, which has 4G and 5G capability. So Raemis today has 4G and 5G capability, and again, it's not obvious to the end user what the difference is. Again, we try to hide that, we try to abstract that, try to keep it simple and try to keep a uniform view. Just to finish up and to go back to my slides, we mentioned, or Tig mentioned that we are radio agnostic. So these are again a sample of radio partners that we would have deployments with. Again, as you can see, it's far-reaching from in-building, outdoor, near patrol, military solutions, and fixed wireless access. So again, reusing your existing investments or expanding or having that flexibility, I guess, may be key to your business. So we support that. lastly, I'll just talk about what Raemis is in terms of deployment options and software. So Raemis is a piece of software, right? It's an EPC. It's written in software. Sorry, just software only. So there's no hardware dependencies. It's uses the Linux operating system. That's our default build. It is portable, but we generally release this on CentOS 7. Usually on an x86 or Intel type processor. Again, it is portable, but this is our reference platform. This is our GA release is on a Linux platform on an x86 type architecture processor. Because it's software and because its only dependency is CentOS 7, that gives us a huge amount of flexibility in terms of deployment option. So whether you want to, host it in your data center and you want to use a Dell, 1U2U server, whether you're putting into, into the cloud, whether you're deploying this at the customer site, whether you have point of presence in different locations, with two or three instances of the software at different geographical locations, providing a level of redundancy. All of that's possible. You can see it can be deployed in AWS, Azure. It's been on AWS Edge Systems, Azure Edge Systems, VMware LXC containers, OpenStack. Again, anywhere that you can run CentOS 7, you should be able to run Raemis. Hardware requirements. Again, I just guess a rough guide. Roughly speaking, it usually takes about 4 cores to run the system, 4 gigabytes of RAM with 50 gigabytes of storage. The requirement being that you have a fast disk, like an SSD drive. So it's, as you can see, the footprint is very, very small. And as a rule of thumb, I would say for every 10,000 users that you're adding to the system, you add 1 core. And for every 2.5 gigabits per second of throughput, you're going to add another core. And there's just some kind of rough estimates there, rough guidelines. But that should give you a sense of what's required to run the system. Again, flexibility and scalability, and not only scaling up, but also scaling down. And with that, I think I'll finish up and hand back to Tig, I guess.
Thanks, Derek. That was great. So hopefully you can see my screen there and the case study on public schools. So let's talk about this one in particular. This is a really common one we see turning up with ISP supplies and ourselves again and again. And I think the COVID pandemic has probably accelerated this one. I have 2 young kids here back in Ireland, so I know only too well how important it is to have access to the internet at the moment, to access their school lessons and to be able to upload the work we've done every day. And in the US, we can see now low income levels, almost half of households don't have broadband access. So we can see already in Texas, Florida, Arizona, and Georgia that there's a scramble to provide internet activity. They're not able to go to the schools anymore necessarily, and to be able to give them internet activity at home. In addition to this, we've had examples last month as well, where we've deployed in rural Pennsylvania and rural Massachusetts for workers at home, etc. So the ability to be able to deploy cost effectively and quickly for these kind of scenarios is really, really important. And we're seeing a lot of business. If there's a bounce at all due to the pandemic, it's in the area of fixed wireless access and also healthcare, where we have examples where we've deployed for temporary testing areas at hospitals, etc. And then just moving on to the next one. So how to get started, I'll hand back to Jonathan to cover this one.
Excellent. Thank you very much, Tig and Derek, for preparing that presentation today and for going over all the info and that live demo as well. We do have some questions to review. One of the questions is, why would you use CBRS on Go for fixed wireless access?
Okay, maybe I'll start, and Derek or Ken, if you have any comments after that. I think the fact that it's dedicated spectrum, Jonathan, is really, really important. It doesn't suffer from interference like some other wireless technologies, and there's lots of spectrum available for it. I think if you look at the public schools examples that we just showed there, and the ability to be able to rapidly deploy and cost effectively deploy the technology, because it's needed now with the COVID pandemic. You know, I think the fact that CBRS and Ongo is there with oodles of spectrum, and the fact that we can use it is really, really important for fixed wireless access. Guys, would you have anything to add to that?
Yeah, I think that's correct, Tyg. I think the fact that it's it's regulated, you know, it's not the free for all. Like a lot of our business in the past has been, replacing existing Wi-Fi systems and other radio technologies with 3GPP technology, which is seen as very stable, very high quality. A lot of devices, etc. So yeah, I think I'd agree with that.
Thank you. Another question is, do you have any examples of where you have deployed in the US so far?
Yeah, so again, I might start there and see where the guys want to chip in, but a number of public schools, as you can see there with Airspan and yourselves. In addition to that, the ones we can talk about are entertainment and retail for American Dream in New Jersey. That's a really, really interesting campus of a mixture of entertainment and retail, where we've deployed as coverage for IoT, etc. Signage. Coverage for hospitality is also out there, and casino security is out there in the public domain already. And then probably more discreetly, we're working on projects in industry in the US already, logistics companies. There's dozens and dozens of examples, in the US so far that we're working on, Jonathan.
Thank you very much. Another question is, what are the key benefits of using Raemis FWA?
Yeah, so I think we've covered that really well so far. I would reiterate, what Derek showed there in great detail, the simple management interface. That's so important, to take away the complexities of a 3GPP network and to make it really workable and easy to use. And then the agnostic eNode B and CPE point, that's really, really important. We can see a lot of the projects so far, there may be bicells, there may be Telrad, there may be Airspan, small cells going in there. And the ability to be able to work with all these different small cells is really, really important. The integration with the CRM, Derek went into detail there on the networking capability, really, really important. And the scalability, I suppose that's one of the first ones I often mention. The ability to scale down is really, really important, I think, because these networks often start small and then they grow right up, into the hundreds of thousands. And then 5G, everybody asks about 5G, what's your roadmap to 5G? And we're at the cutting edge of that. And we've made that really, really easy to transition across once the ecosystem is fully developed there. That's what I would say. Guys, do you have anything to add?
Yeah, I think, again, Tyg, I think you're just reiterating that, for me, it's all about simplicity. I think it's fit for purpose. It's designed specifically, from the enterprise and from the fixed wireless access point of view. We're not trying to put a consumer core into this environment. We're actually coming with the requirements and the use cases in mind. And again, flexibility. I think it's just that flexibility with our REST API enabling you to do things and do things in a unique way or in a way that may suit your business. Through our REST API, it's all possible. So at a technical level, I think it's simplicity and flexibility.
Thank you very much. And the last one here is, how long has Druid been deploying FWA networks?
So again, I would say there, I suppose as we showed, we've been deploying private networks for nearly 20 years, but fixed wireless access in particular, I guess that goes back a number of years in Asia already with our global OEM partners. What do you reckon, Derek? Would you have any comments on that?
Yeah, no, I think again, fixed wireless access, our earliest markets would have been Japan, that's for sure. We do have a number of deployments across Northern Europe, and again, we're rolling out a number in the US, but there's a big one we're doing in the US at the moment, with a large ISP. So we've been, I guess, 5 years is probably when we started our first 4G fixed wireless access deployment in Japan and Northern Europe. And again, there's the technology and the principles of fixed wireless. They're kind of true and they hang. That's very similar in a lot of our use cases. So, for example, we would have a lot of deployments in covering large areas of ocean, for example, for wind turbines and oil refineries, etc. That's very, very similar to the fixed wireless access case. Actually, it's identical almost, except that the number of consumers are relatively low, but it's the same principles. So it's yeah, 5 years, I guess, is the answer to that question.
Yeah,
Excellent.
yeah, and then I guess I would say, Jonathan, we're seeing it accelerate as well at the moment. As I mentioned earlier there with the COVID pandemic and the rush to connect people at home, there's definitely an acceleration going on at the moment. And it's an ideal one, I guess, for on-go CBRS spectrum as well. The amount of CPE equipment and SD, what are they called, the small cells for on-go CBSDs, the amount of those that are available as well to just hit the ground running and deploy is really helping.
Excellent. Thank you very much. That wraps up all of the questions. And if anybody would like to start taking a look at potential design and build of their network, if you can please shoot us an email for any type of support or initial setup inquiries. You can reach Mr. David Peterson, who's our senior engineer at ISP Supplies. You can email him at support@ispsupplies.com. And also our sales engineer, Mr. Dan Ortega, for any type of pricing and availability inquiry. You can reach out to him at dano@ispsupplies.com. That's DANO@ispsupplies.com. And we would like to thank everybody listening to this webinar today. For more information and to go over pricing, please reach out to us. We'll also be posting and recording a recording of this presentation on our YouTube channel as well as our Facebook page. So please follow and subscribe to us. So thanks once again, gentlemen, for joining us today and for going over all the information. And I'd like to wish everybody here a great rest of your week. And God bless everyone.
Thanks, Jonathan.
Thank you.
Appreciate it.